Bismillahirrahmanirrahim and Assalamu alaikum to every one of you. So today we are going to be implementing discrete Fourier transform inside the scientific calculator. Now as we all know that calculating the DFT of a given discrete signal takes some time, and it's good to have a method that can quickly verify if you have manually calculated the DFT of a signal or just you want to find a DFT of a 4.8.6 point given signal. So it's very simple. The first step is to put the calculator in the complex mode. It's already in the complex mode, but if you don't know, just type mode and go to the complex mode. Okay, now when you are in the complex mode, the second step is that you have to find the value of n. Now as an example, I'm taking n equals to 4. I'm taking only 4 samples of a given discrete time signal. Okay, so this is 1 2 3 4. These are 4 samples. Now that means n equals to 4. So divide 360 by n. So I'm dividing 360 by 4, that gives me 90. Okay, so I got the angle 90. Now the third step is to input the data into the calculator and simply calculate. So how to input that data in the calculator? So it's very simple. Just type the numbers that are given, that is 1. Okay, sorry. So just type in the numbers simply like 1, then shift angle, and the first angle is usually -0, then alpha a. So every sample should be input like this. Okay, now why I have calculated this 90 degree, that means you have to add this angle with the corresponding sample. Like if I start with one angle -0, then the next sample would be like the second sample with an angle of -90, -180, -270 and so on. Okay, now if n equals to 6, 360 divided by 6 would give me 60. So then the next angle would have been -60, -120, -180, -240, -300. Okay, so just input it like this, then plus the second sample is 2 with an angle of, now it would be -90 a. Oops. Okay, then okay, I'm inputting the data and fast forwarding the video. So okay, so once you have done typing all the input data in the calculator, so then just hit alpha and then to automate the process, so a would be equal to a plus 1. That means increment a by 1 every time I hit the calc button. So now just simply tap that calc button and give the input to the a starting point, that would be 0. So that would give me 10. That means that x of 0 equals to 10. Now the second input would be 1, so that would give me -2 plus 2j, means that's the second sample in the frequency domain. Okay, likewise the third sample is -2 and the fourth would be -2 -2j. Let's see. Okay, So that's how you can easily and quickly find the DFT inside the scientific calculator. Now what will happen if I give a equals to 4? I mean, I'm going more than the size of n. So as we know, the properties of DFT, that or even the properties of Fourier transform in the discrete domain, that after every n the cycle repeats. Okay, so let's see, again it's 10, so it means this sequence will be repeated. Let's see. Okay, so that's how you can easily find the DFT using scientific calculator. I hope that helps. Thank you for watching the video.